I'm Anil Kumar. Welcome to my series on calculus. Many students have joined me in learning through Zoom, through my videos, and the worksheets and examination style test papers. You can always contact me on my email, which is given here, and on the website globalmathinstitute.com to register and learn more. In this particular video, we'll talk about the chain rule. Chain rule is applied when we have composition of functions. So we'll touch upon the concept of composition of functions. Then we'll discuss the chain rule, the formula applied. This chain rule formula we actually discussed earlier also while taking a power rule. So chain rule, power rule can be combined, and it's a very effective formula which some of you must have practiced when we were doing Unit 3. Now, we'll take further examples where the chain rule will be applied, and these questions are actually taken from previous test papers. So I hope you find them interesting and useful. So we'll talk about this particular flow, which is one function after the other, correct? So that is kind of a chain which you look into. Now let's see what really composition of function is. So in composition of function, we have more than one function. So when we say that the composition of a function f of x with g of x, we'll write this as f of g, right? So this is the operator of composition. So that small o in the center is basically the operator for the composition. And this is read as f of g. Or it could be written as f is a function of g, which is also a function of x. So both are functions of x, correct? So here, f of x, which is right here, we call this as the outside function, right? So this f of x is the outside function, and g of x is the inside function. So we'll just give these terms. They're not very standard, but normally used. So this is outside function, and this one is the inside function. Sometimes we also call this as an argument, right? Especially when we use trigonometric functions, we may refer to g of x as inside function or also as an argument, like sine theta, right? Theta is the argument. In this case, outside the output of g of x, so when we write like this, f of g of x, it really means that the output of g of x becomes the input to f of x. And in a flow diagram, we can show as shown here. So if there is an input of x, then first the operation is performed by g, that is the inside function, right? So you get g of x as the output. This output acts as an input to the outer function f, and you get the composite function f of g of x. Is that clear to you? Right? So that is how we can see the composition of function. To give you an example, let's say capital F of x is a function which is given by square root of x squared minus 4. So we can treat x squared minus 4 as the inside function and square root as the outside function, correct? So what we have done here is we have written the function, outside function, as square root of u, and we have defined u as the inside function, right, which is x squared minus 4. You get the idea, right? So this is the function of x, so I'm writing u as g of x. So we have a composition f of g of x where g of x is x squared minus 4 as written here. So it becomes f of x squared minus 4, which you could write in square root of x squared minus 4, and that becomes the function itself. So you can see how we are actually looking at the composition of functions. Perfect. Now here are two questions for you. Question number 1a. Write down the range, domain and range of the function f of x, right? That is for you. So domain and range of f of x, this is a square root function, correct? Now, part B is evaluate u and f of minus 3 if it exists. Sometimes it may not exist, right? So you may have to figure this out. So these are two questions for you. Try them out. Write your solution in the comments. I can always get back to you with the correct solution. Now here is the next slide where we'll talk about chain rule now. So understanding composite function is very important for chain rule, and you should understand that we have an outside function which is this, and g of x is the inside function when we write f of g of x, correct? Now think about derivatives as rate of change, right? So when you have rate of change, which derivative really is, then it is easy to understand the chain rule. So the operation of the outside function on the result of the inside function is what chain rule is, correct? So as we have seen here, in the case of chain rule, f of x is the outside function which works on the result of inside function. Result is the output g of x, right? That is what the function is, okay? Now, consider derivatives as rate of change. Then we can say u of x, let's write down u as g of x, right? Let me write u as equal to g of x. In that case, u is a derivative. We can take derivative of u is a function of x. Du dx is rate of change of u with respect to x, correct? So du dx is rate of change of u with respect to x. And dy du is rate of change of y with respect to u. That is the denominator, right? That is the basic definition of derivatives. But when we write dy dx, then dy dx is rate of change of y with respect to x, right? That is their understanding. Now think like this. We have something and we say, well, the rate of change of du dx is, let us say, 2, right? And the rate of change of dy du is 3. Then what will be the rate of change of dy dx? They will get multiplied, right? So it will be 6. Is that correct? Right? So if inside function increases by a factor of 2 and the outside function by 3, net result will be they get multiplied and you get 6. So that is kind of base behind our logic, that dy dx is basically dy du times du dx, and that becomes the formula for chain rule, right? So this is your formula. So to find dy dx, we need to multiply the dy du by du dx, correct? So they are derivatives. So we could also write this in the form d dx of f of g of x is equal to derivative of g, derivative of f of x, the outer function, times the derivative of inside function. You get an idea, right? So this is this du dx, right? So in this case, you could write in different ways. Now, you could also have many functions, more than 2 also. Let us say we have 3 functions. I like you to write down the formula for chain rule for d dx of f of g of h of x, right? So we have 3 different functions here. Now let's take some examples to understand the concept. Example 1 is that if y is equal to x squared minus 3x plus 5 to the power of pi, find dy dx, right? Let's see how to write the solution for this. So we can actually use the combination of power rule with the chain rule. See how. We can define the inside function as u, right? So that's what we did. So we could say that let u equals to u square minus 3x plus 5. Perfect. Now once we define this inside function as u, you can find the derivative of u with respect to x. So you get 2x minus 3, right? So that is du dx. Now, we know that y is equal to all this, and if inside function is u, then we can write y as u to the power of pi, since we know that u is equal to x squared minus 3x plus 5, correct? So in short, we write y equals to u to the power of pi. Now, we can have derivative of y with u using the power rule. We get pi times u to the power of pi minus 1. That's the power rule. Now you can substitute the value of u and get the result. Is that clear to you? Perfect. So broadly speaking, what we have done here is we have multiplied the whole. You use the power rule on this, correct? And then you have multiplied with the derivative of inside function, right? So now we can say dy dx, the chain rule application, dy dx is dy du times du dx. So we can multiply these two and get our result. Is that clear to you? So dy dx will be dy du, which is right there, times du dx, which is 2x minus 3, right? Now, this could be done straight using power rule combination with the chain rule. Now, this is very popular, and therefore, it is better to write it in one step rather than, showing all these steps as shown here. So basically, we have to find the derivative of u to the power of n. It is n times u to the power of n minus 1 times du dx, derivative of inside function. Is that clear? So you can apply that directly and then write down the answer. So if I have to apply the rule, I'll write this as y is equal to x squared minus 3x plus 5 to the power of pi. In that case, I'll write y dash will be pi times, pi is a number, okay, x squared minus 3x plus 5 to the power of pi minus 1, right, times derivative of inside function, which is, or we can do one thing, derivative of inside function, which is x squared minus 3x plus 5. Is that clear to you? So this derivative is what this is, 2x minus 3, and you get your result. Is that clear to you? Right? So you could straight away write in this particular form. We are going to use this in some of our examples, so I think this point will be absolutely clear. Let's take example number 2 now. Now we have two functions. The question is, find dy dx at the indicated value of x. Y equals to 2u cubed plus 3u squared, where u is x plus 1 over square root of x, and we need to find dy dx at x equals to 1. So now, since we know what u is, you can find what is du dx, right? So derivative of 1 is x is 1, and 1 over square root x means you would also write this as equal to x plus x to the power of minus half. If it becomes simpler for you, then we can apply the power rule. We get minus half x to the power of minus half minus 1, which is minus 3 by 2. Now you can write with the value x equals to 1, since we need to find the derivative of this particular function at x equals to 1, right? So substitute 1 for x and get your result. That is du dx at x equals to 1. Now, we're given y as a polynomial function. We can also find its derivative with respect to u, which is 6u squared plus 6u. Now, at x equals to 1, u is equal to 1 plus 1 over square root 1, which is equal to 2. So, you can substitute 2 and get dy du at x equals to 1, substituting 2 for u, we get this value is 36. Now, we need to find dy dx at x equals to 1, multiply the two results which you've got, and that is your answer. Is that clear to you? So that is how we are going to actually solve such questions. Now let's take the next example, which is example number 3. If y equals to f of u and u equals to g of x, express dy dx in terms of dy du for u equals to square root of 11 minus x squared. Now, we know what u is, so we can find du dx, so which is half of within square root in the denominator 11 minus x times the inside function. So at this stage we have applied the power rule combination, right? So we have done power rule plus chain rule. Correct? So that is what we did. Remember, we are writing u as 11 minus x squared to the power of half. So when you want to find du dx, it will be equal to half times 11 minus x squared to the power of half minus 1, which is minus half, times the derivative of inside function, which is 11 minus x squared. Is that clear to you? Right? So derivative of inside function, which is 11 minus x squared. I missed 11 here. Okay. So let me write down 11 clearly. 11 minus x squared. So that is what you get as written here. Perfect. So 11 minus x squared. Now derivative of 11 minus x squared is minus 2x, which I have written right there. So minus 2x is the derivative of 11 minus x squared, and already we had 1 over 2 times square root of 11 minus x squared. Now 2 and 2 cancel, so you get your result, which is minus x over square root of 11 minus x squared. Now, the question is, if y equals to f of u and u equals to g of x, express dy dx in terms of dy du for u equals to square root of 11 minus x squared. So dy dx is dy du times du dx. We already have what du dx is. Substitute that particular value, right? So we get the result in terms of dy du. That's what we want, and that's the result. So it's a tricky question, but that is how you could rephrase and write down your answer. I hope it makes sense, right? So let's continue and now take up example number 4. Example number 4. This is from previous test paper. It's a very important question. I like your full attention to understand the question and then solve it. If f of 3 equals to 4, derivative of f at 3 is minus 1, derivative of f at 6 is 5, g of 3 is 6, and g prime 3 is equal to 2. Determine, there are two parts to it, f of g derivative at x equals to 3, and we have fg derivative at x equals to 3. You can pause the video, answer this question, and then look into my suggestions. Now, it's important to understand the difference between the two. So here we are talking about the chain rule, correct? So this is what we say is chain rule, right? And this is product rule. So product of two functions, their derivative. So that is a huge difference, and you should actually understand this. Now once you've understood, now it's easy to find the solution. So the very first one, we'll apply the chain rule. So f of g, we need to find the derivative of this with respect to x. So we need to first differentiate with outside function, multiply with the derivative of inside function, correct? So f of g derivative at 3 will be f prime g3, right? So we replaced x with 3, g prime 3. Now we can read the values. What is g of 3 equals to? So g of 3 is given to us as 6. So we'll replace that with 6. So we get f prime of 6, correct? On the other hand, G prime of 3 is what? G prime of 3 is 2. So we'll replace this by G prime of 3 as 2 later. Anyway, F prime of 6, let's look for that. F prime of 6 is 5. So I'll replace F prime of 6 by 5. So when you multiply F prime of 6 with G prime of 3, you get 5 times 2, 10 as your result. Is that clear to you? Perfect. Now let's take the other one, which is basically a product rule. Now that means the derivative of the first one times the second plus first times the derivative of the second. So written at x equals to 3, derivative of first at 3 times the value of the function at 3 for the second. Value of the first function at 3, derivative of the second at 3. We can now read the values from there. F prime 3 is minus 1. G3 is given to us as 6, right? There you go. F of 3 is given to us as 4. And G prime 3 is 2, right? So substitute these values. Minus 6 plus 8 is 2. That becomes the answer. Is that clear? So go through this once again. Understand the nomenclature. So here we're talking about chain rule, and in this case it is the product rule. Okay, so these two are very different things. Let's see example number 5 now, which is also a very interesting question. If y equals to f of 3 times x to the power of 4, that means f of this is your function, right? Inside function. And f prime 3 is minus 5, determine dy dx at x equals to 1. That's the question. You can always pause the video and answer this particular question. Well, the solution is straightforward. We have chain rule to be applied here. So find the derivative of this function times the derivative of inside function. Is that clear to you? Right? Now, since we are working at x equals to 1, we need to find at x equals to 1, we could always substitute the value 1 inside. Okay. Now, if I substitute 1 in there, then what do we get? F prime of 3x to the power of 4, substituting 1 gives us just 3, right? So I've substituted 1 here. And let me write down here. We are substituting x equals to 1, and then we are writing the values. Right. Is that clear? So when I write 1 here, we get f prime of 3, which I've written here, and 12x cubed. So 12x cubed, x is 1, and so it is 12. From where did we get 12x cubed? This was the derivative of 3x to the power of 4. Right? So that is how we got 12x cubed. Now you substitute x equals to 1, and then f prime 3 is given to us as minus 5. So we substitute minus 5 for f prime 3, and when you multiply, you get the result minus 60. Right? So that is how the chain rule could be applied in many different ways. So these are the type of questions which you should be expecting in a test paper. Here is the very last example for you, where we'll combine the power chain rule and we'll do it twice. Okay, so the question here is, if y equals to square root of x plus square root of x squared plus 2x plus 1, determine dy dx. Okay? You can always pause the video, answer this particular question. We'll actually apply the power rule combination with the chain rule. So the outside function is a square root function. So square root function derivative is 1 over 2 square root of everything. Do you understand? Outside function is the square root function. Derivative is 1 over 2, and the square root function comes as such in the denominator. Now, derivative of inside function. Do you see that? This inside function derivative we have to multiply by. So that is the part of chain rule. You see that? This is chain rule. And this part here was power rule. So that is how we are going to combine it. Now, You need to find the derivative of the inside function, which is right there. Derivative of x is 1, so we get derivative of x is 1. And now that square root function, you have to again apply the chain rule. Do you see that? So we are applying the chain rule once again. So second time chain rule. Correct? And then you get 1 over 2 square root of x square plus 2x plus 1 dy dx of x square plus 2x plus 1, which is the inside function. Is that clear? Which is this inside function, right? And the derivative of this is 2x plus 2. Now you can simplify and write down your result. So that is how you should be doing it. Now, here is a worksheet for you, which has 8 examples. We already had 2 questions earlier, and therefore, so we had question 1 and question 2 earlier, right? This begins with question number 3. Find derivative of the following functions. So we have derivative of these 4 questions for you. That's the first part. So you can apply the power rule, chain rule combination. The very first one, f of x is 4x cubed plus 2x squared minus 5 to the power of 3 over 4. The second one, you may apply double chain rule, right? Power rule, chain rule twice. When you have square root within square root, then that means multiple times you may have to apply this combination of power and chain rule. Now question number 5 is similar kind. So again 5, which is your power rule, and then inside function quotient rule with the chain rule. The last one here for finding the dy dx is y equals to x plus cube root of 2x plus x squared to the power of 10. So again multiple times you may have to apply the chain rule, right? So in these examples we see multiple chain rule operation. Correct? Now the next 2 questions are basically thinking questions. So let me write them as tips. These are very important questions. Question number 7 is find ds dt for t equals to 4 if s equals to v plus 100 over v and v is 5t minus 2 square root t. So that could be asked in some applications. We could have a velocity displacement function. So I've written it in short, or we could have a word problem based on this. Is that clear? Right? Question number 8 here is, if f of 5 is equal to 4, f prime 5 is minus 1, f prime 3 is 4, g of 5 is 3, and g prime 5 is 2, determine. It is a similar question. You need to understand which is the chain rule and which is the product rule and get your answer. So I hope that makes sense. That should give you good practice on chain rule. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Next, we'll discuss implicit rule. Thank you.